In this video, we are going to learn some numericals on projectiles which are on the horizontal surface. So before we start with, we'll just brush up with the list of formulas we learned in the last videos about the introduction of projectiles. So this was the equation for path of the projectile. So it's a parabolic equation. Then we have the formula for horizontal range. Then we have the formula for time of flight, then maximum height, then for the conditions of bomb dropping problem, motion of the body thrown horizontally into the air. We have these two equations, one to calculate the time and one to calculate the range. So these are the equations that we need to remember before going to solve the problem. So let's start with the problem. Problem number 1. A projectile is fired with an initial velocity of 40 meters per second at an angle of 25 degrees with the horizontal. Determine the horizontal range, maximum height attained by the particle, the time of flight. So it's an easy problem, very direct problem. Just if you know those equations, it's a direct substitution problem. So what are all the data given? They have given the velocity of projection, that is u, is equal to 40 meters per second. Then the angle of projection alpha is equal to 25 degrees. First, they have asked you to find out the horizontal range. We know the formula for horizontal range. Then substitute u and alpha in the equation r is equal to u square sine 2 alpha by g. We know that g is equal to 9.81. Substitute all the values and you get, when you solve, r is equal to 124.94 meter. After this, they have asked, the second part is maximum height attained. We know that the formula for that is h is equal to u square sine square alpha by 2g. Substitute u, alpha and g in the power equation, and when you solve, you get it as 14.56 meter. Then the third part comes as time of flight. We know the equation t is equal to 2u sine alpha by g. Substitute the value of u and alpha and g. When you solve, you get t is equal to 3.446 seconds. So these three things they have asked and we arrived at the answers. Moving to the problem number 2. A projectile is fired at certain angle with the horizontal has a horizontal range of 3.5 kilometer. If the maximum height reached is 500 meter, what is the angle of elevation of the cannon? What was the muzzle velocity of the projectile? If you're seeing what is cannon, this one you would have seen it. So muzzle velocity means the initial velocity. This is called as the muzzle. So it's the muzzle velocity. Taking of the solution, given r is given as, the range is given as 3.5 kilometer. We want it in meters, so we convert it into 3,500 meter. Then the maximum height is reached as 500 meter. So alpha, we will take it as the angle of projection. So we know that projectile range, they have given the value of range. We know the equation for it. R is equal to u square sine 2 alpha by g equated to 3,500 and call that as equation number 1. Then they have given maximum height. So we know the equation for that also. U square sine square alpha by 2g equated to 500 and call this as equation number 2. From this equation number 2, you can write u square is equal to 500 into 2g by sine square alpha. From equation number 2 itself, we are deriving for u square. And you call this u square equation as equation number 3. Now what you do is substitute this equation number 3 in equation number 1. This one in this equation for u square. If you substitute, you get this. So when you substitute this, u square you're going to replace with this term into sine 2 alpha by g is equal to 3500. On for this solving this, you get GG gets cancelled, so 1000 sine 2 alpha by sine square alpha is equal to 3500. Taking it further, I elaborate sine 2 alpha as 2 sine alpha into cos alpha, then sine cos becomes tan, sine gets cancelled. So 2 cos alpha by sine alpha is equal to 3500. It gets converted to tan alpha. Then tan alpha will be equal to 0.57 when you further solve it. And you get alpha is equal to 29.75 degree. So we got the angle of projection. So substituting this alpha in equation number 1, what we get, u is unknown. So find u. You will get it as u is equal to 199.62 meter per second. So you've got alpha and the velocity, initial velocity. So next type of set of problem what we see is a person standing on a cliff of certain height or from a certain height is going to throw this projectile. Usually a typical problem used to be like a person used to throw the projectile or whatever the particle is projected from the ground, it goes up and comes back to the ground. But here it is going to start at certain height, then it's going to come down. And see a demonstration here, which I have borrowed from Google. So this is the way the projectile is thrown. So coming to problem number 3, which is dependent on that cliff problem. A projectile is fired from the top of cliff 150-meter height with an initial velocity of 180 meter per second at an angle of elevation of 30 degree with the horizontal. Neglecting air resistance, determine the greatest elevation above the cliff. Then the great elevation above the ground reached by the particle. The third one is the horizontal distance from the gun to the point where the projectile strikes the ground. On to the solution. Given initial velocity 180 meter per second, they have given an alpha angle of projection is given as 30 degree. So I can write it this way. Since the projectile is starting from a cliff, the cliff height is given as 150 meter. From here, it's thrown with a velocity, initial velocity of 180 meter per second with an angle of 30 degree with respect to the horizontal. It is going to reach a maximum height and then it comes back. So from the cliff, whatever the height is there, maximum height reached is we call here as h. The cliff height is 150 meter. From the ground, if you want to find out the maximum height, it will be h1. That is nothing but 150 plus h. So we are going to calculate this h. Then we are going to calculate this h1. Then we are going to calculate this range, the distance, horizontal distance from here to here. 3 things. So let h be the greatest height reached by the particle above the cliff. That's the first target for us to find out. So we know that for a normal projectile, h is equal to u square sine square alpha by 2g. We know u, alpha, substitute everything, you will get the maximum height reached by a normal projectile, because normal projectile starts from one point and comes back to the same level. So for this thing, this height equation applies here. So we get h is equal to 412.84 meter. Next one we have to find is the maximum height above the ground. That is h1. We will get when we add 150 plus h. See here, greatest height above the ground level, that is nothing but h1 is equal to h plus 150. H we have already known. Substitute, you will get h1 is equal to 562.84 meters. Simple. Two things are done. The last one is you have to find the range. Horizontal distance from O to A. What is the horizontal distance? Let T1 be the time taken by the projectile to reach to the maximum height. We will take depending upon the time. First we will find out the time. We know the speed, so distance can be easily found out. So we'll depend upon the time first. So let T1 be the time taken by the projectile to reach the maximum height. So from here to here, it will take a maximum of T1 seconds. So T1 will be nothing but So for a normal projectile to start from a certain level and come back to the same level, we know that time of flight is equal to 2u sine alpha by g. But you just want to know only for this much portion, so you just take half of the time of flight, the normal time of flight. So t1 will be half of the time of flight. So substitute, simplify further and substitute, you will get t1 is equal to 9.17 seconds. So the projectile will take about 9.17 seconds to reach till this maximum height. So this is t1. So the remaining we want to this the time taken by the projectile to reach from this maximum height to the ground. That we'll call it as t2. That's in the next portion. So till now we have the greatest height is the maximum height, that is 562.84, and t1 second is 9.17 seconds. So consider the motion of the projectile from the maximum height. After it reaches the maximum height, it's going to fall down. No? So from the maximum height to ground due to the gravitational acceleration. Since it goes to some certain height, due to gravitational acceleration, it's going to drop down. So that is when it is going to drop down there, it will lose its velocity. I mean the vertical velocity. We are going to consider in the vertical direction, right? So in the vertical direction, maximum height is 562.84, and there will be only horizontal velocity. There won't be any vertical velocity. It loses its vertical velocity, that's why it comes down. So I'll take it as 0, and height, maximum height, distance, I'll take it as 562.84 meter. Let T2 be the time taken. So we can consider the equation of motion, that is S is equal to ut plus half gt square in the vertical direction. So we know the value of S, u is 0, g you know. You can find out t. Here t we will call it as t2 since we are calculating for the next half of the problem. So t2, when we further solve, we'll get it as 10.71 seconds. So to reach the maximum height, it took 9.17 seconds. Then to come back from the maximum height to the ground, it will take 10.71 seconds. So therefore, the total time of flight to reach the ground from the starting point will be t is equal to t1 plus t2. Add those two values, you'll get the total time of flight for this problem, 19.88 seconds. So it's not done yet. You need to calculate the distance from O to A. So you know the time, you know the velocity. So distance from the gun to the point where the projectile strikes the ground will be range. Distance or range is equal to the horizontal. Since you are calculating the range in the horizontal direction, I'll take horizontal component of the velocity into total time taken by it. So R is equal to 180 cos 30. That is the horizontal component into 19.88. If I do, I'll get the answer as 3099 meters. I can convert back into, since it's a big number, I'll convert back into kilometers. So the range will be 3.099 kilometers. So this problem is done. It's an easy one. Just need to understand that we have to divide the time into two parts. One till you reach the maximum height, and then after reaching maximum height when it reaches the ground. So T1 and T2. This is the major part in this. Moving to the next problem, problem number 4. An aircraft is moving horizontally at 108 km per hour at an altitude of 1000 meter towards a target on the ground. Releases a bomb which hits it. Find the horizontal distance of the aircraft which releases the bomb from the target. So this is the bomb dropping problem, which we learned something in the last video. Also determine the direction and velocity of the bomb when it hits the target. Neglect air friction. You should also find out the direction, that's the angle, and the velocity with which it reaches the ground. So let's see when all is given. Horizontal velocity, that is 108 kmph they have given, but the standard is we want it in meter per seconds. So convert it into meter per second, you get 30 meter per second. Then the altitude, at the altitude with which the aircraft is traveling from the ground level, that is S is equal to 1000 meter. The vertical motion of the bomb is due to the gravitational acceleration only. So due to gravity, it is going to descend down from the 1000-meter height. So let t be the time of flight. Therefore, I can take, you know, we have learned that equation. So s is equal to half gt square. We are not going to take ut because in the vertical direction, the velocity will be 0. So obviously it is going to be 0 here. So s is equal to half gt square. We know the height s, we know g. Therefore, can we calculate t? So we got t is equal to 14.27 seconds. So this is the time taken by the bomb to reach from the aircraft to the ground. Next, the horizontal distance or range of the aircraft from the target. So what is the horizontal distance traveled by that bomb? So we have horizontal distance is equal to horizontal velocity into time. We know the time is 14.27 seconds and horizontal velocity is 30 meter per second. Therefore, substitute, you get it as 428.1 meter. So two parts are done. The next part, direction and velocity with which the bomb hits the target. That's the important part now. So let alpha be the angle with which it hits the ground. I'm going to take this alpha with respect to the vertical line. You can see here, this point is when it reaches the ground level. It is going to reach the ground level with this velocity. Some velocity we don't know, we need to find out. We know the horizontal velocity is 30 meter per second and vertical velocity you need to calculate. That is, and the angle alpha is with respect to the vertical. So if Vv is the vertical velocity after 14.27 seconds, then we know that final velocity is equal to initial velocity plus gt. Substitute that. Initial velocity is, it's in vertical directions, obviously it is going to be 0. G is 9.81 and t we know 14.27 seconds. So that's how you get this 140 meter per second. So you know the horizontal velocity, you know the vertical velocity. So apply tan alpha is equal to tan alpha, if you're going to take this triangle, opposite by adjacent. So 30 by 140 if you take. If you solve further, you get alpha is equal to 12.09 degree. And you also want to know what's the resultant velocity. You already know the equation. VR is equal to square root of horizontal component square plus vertical component square. Substitute for those values as 30 and 140. And further you solve, you get it as resulting velocity will be equal to 143.18 meter per second. So the bomb is going to reach the ground with a velocity of 143.18 meter per second, making an angle of 12.09 degree with respect to the vertical line. So this problem is done. So the next problem, problem number 5, a cricket ball is thrown by a fielder in the ground from a height of 3 meter at an angle of 40 degree with horizontal. The velocity with which the ball is thrown is 30 meter per second. The ball hits the wicket at a height of 0.3 meter from the ground. Determine the distance of the fielder from the wicket when the ball is thrown. So it's a cricket problem now. So what are the data given? They have given the initial velocity with which the ball is thrown, that is 30 meter per second. Then with which angle he has thrown is also given with respect to horizontal, that is alpha is equal to 40 degree. So you can write it like this. So he is going to start at a height of 3 meter. So he's going to throw the ball at a height of 3 meter with a velocity of 30 meter per second, making an angle of 45 degree. It is going to go up and come down and reach not the ground with the stump at a height of, with the stump which is at a height of 0.3. So this total height is 3 meter. This is 0.3. And if you want to know the remaining one, you just deduct this and you get it as 2.7 meter. So you know all these heights. They have asked you to find out this horizontal distance. What is the distance between this bowler and the wickets? So you need to find out the horizontal distance. So this is particularly dealing with you have all other datas. This is just dealing with your x value and y value. So why, since it's traveling a parabolic path, why don't we take the equation of path of the projectile here, right? So the velocity with which the ball is thrown is 30 meter per second. So as I said, I'm going to take, let x and y be the coordinates of the point on wicket with respect to the top of the fielder. So the point you see here, it's an unknown point. Let's call x comma y to be the coordinates of that point. Okay, so we need to find that x will be this and y, we know it. So when y is equal to 2.7 meter, what is x? We need to find out. So at this point, we know that if we are taking this the starting point now, this is the origin point. So if we are taking this as to be the zero line, zero x line, zero y line, with the zero line, this is, we are going to measure it down, right? So it will be, y will be, for this point will be minus 2.7. X will be positive itself, but what is this x? We need to find out. So make use of the equation of the path traced by the ball. That is y is equal to x tan alpha minus gx square by 2u square cos square alpha, which we have derived also and we are remembering it. So substitute here, u is already known, g you know it, and alpha also you already know it. X you have x you need to find out, but y you have to substitute it as minus 2.7. Substituting all these things, substituting it here, and for the solving, you get this. So you know that you can form a quadratic equation. To start with, I want it as x squared. So I make further adjustments and I get x squared minus 90.32x minus 290.32 is equal to 0. Basically, by dividing throughout the equation 0.0093. So I know how to get the solution for that. X is equal to minus b plus or minus root of b square minus 4ac divided by 2a. On substituting this and for the solving, we get x is equal to 93.42 meter. We know that we have to get x to be positive. So we take the positive value, x is equal to 93.42 meter. So the distance between the bowler and the stump will be 93.42 meter. So these are the references made for this particular video. Thank you so much for watching this video. Let's see further problems in the next part of this video.